We already took a little bit of a look at this evaluating these functions with function notation in the last section that we did, but we'll take another look at it. It's an extremely important idea to understand what this function notation actually means. So when I've got f of 3, that means that I'm using the f function, so I'm using this function, and f of 3 means that I've got x equal 3 in this function. So f of 3 is equal to 3 times 3 plus 4 rather. And 3 times 3 is 9. 9 plus 4 gives me 13. Okay, so pretty quick and easy when I'm looking at the basic idea. Well, when I jump down, let's do one that has, let's do one that's k, function k, like number 5. So I'm taking the k function and I'm plugging in a -1. So I get 2 times -1 minus 9. That's all in absolute value, and then plus 3. 2 times -1 is -2 minus 9, all in absolute value, plus 3. -2 minus 9, if I owe $2 and then I borrow 9 more, if it's -2 degrees and it drops 9 more degrees, any way that you want to think about it, this gives you the absolute value of -11 plus 3. Don't lose the absolute value. It has to go along with this. So absolute value of -11 is positive 11. Absolute value means how far away from 0. So I want to know how far away from 0 is -11. Well, if I were to count on a number line, it's 11 spaces away. Okay, so I've got 11, and then I've still got the plus 3. 11 plus 3, okay, it gives me 14. Okay, so that's one with the k function. Then the last one that I want to take a look at here is one with the m function. And so here's that one right there. Move that out of the way. We've got m of 4, so I'm plugging in 4 for the x value. That's 4 minus 3, and then plus 1. The 4 minus 3 inside the square root is 1. Square root of 1 is 1. 1 plus 1 is 2. So I end up with 2 there. So same thing happens. Let's jump down here quick to number 12. And I'll plug the number in, and then I'll pull the screen up a little bit. So I've got the square root of 12 minus 3 plus 1. And then pull the screen up. 12 minus 3 is 9 plus 1. And then the square root of 9 is 3 plus 1. And 3 plus 1 gives me an answer of 4. And so there's all the rest of these functions. There's a g function, a j function. Make sure you're plugging them in to the problem and then doing the order of operations and simplifying each one of the values. So that side we've already really looked at. This is the side, and 15 through 18 actually go with those front equations as well. This side back here, once you get to the graphs actually are going to be representing or for the problems 20 through 31. Okay, so we'll take a look at, just kidding, through 35, 20 through 35. Thought it stopped there, but just my screen stopped there. So 20 through 35 go with each of these graphs. So I've got F, G, and H. I'm looking at, again, what they're telling me by saying F of 1, it is when x equals 1, I want to figure out what does the y value equal. And on the front of this sheet, when I was figuring out that y value, I was doing it with an equation. So I was plugging the number in, and it was coming back, and it was giving me a value back after I did some order of operations things. On this side, I've got that x equals 1, and there's a bunch of graphs that I have to look at, and I want to find out what the y value is by looking at the graph. Okay, so I've got x is equal to 1 in the f graph. So first thing, make sure you're looking at the right graph. Here's the f graph. At x equals 1, I can follow this down, and my y value is down here at -3. Okay, so that's all I need to figure out. That's what I want to find in this graph, is at the x value, what is the y value? So then I move on to g of 4, so I'm looking at the g function at x equals 4, which is over here. follow that up, and I've got a y value of 3. Okay, so that's what they're asking us. They're asking us for this ordered pair. If I was to name this ordered pair, the ordered pair would be 4, 3. Okay, that is in this function notation. I've got x equals 4 and y equals 3. Okay, so start putting some of these pieces together. I did that same information with equations. Now I have graphed the equations, and I'm plugging these values in to get the y value back again. Except I'm plugging them in to where the graph is. So then here's h of -3. So the h function at -3, follow that up, and on the graph, that place at -3 has a y value of 4. Okay, so again, thinking of other words for these x's and y's. The x is the independent variable, the one that's changing, and then the y is the dependent variable, the one that comes back after we've changed things. The x is the input, the y is the output. The x is the domain, the y is the range. Okay, so when we look at all of this stuff coming together, that's what we're talking about. But let's do one that's maybe a little bit harder here. Like let's say number 32. So I've got f of 0. I want to know what is the function value of f when x is equal to 0. So I come back up to the graph at x equals 0 here. Well, I want to see on the graph, where does that go? So the question is, do I go up or do I go down? Well, the filled in circle means that this is the value that actually works in that point. So filled in circle has the equal to line underneath when we think about using inequalities, set builder notation, things like that. When I've got that line underneath or a filled in circle, that means equal to. And so when I want to know when it's equal to 0, I go up here, I follow it up until I get to y is equal to 4. And so my answer to f of 0 is 4. When x is equal to 0, y is actually equal to 4 because that circle is filled in there. When I go and continue, I look at, let's say, the g of 0. Okay, g of 0, again, the idea is a little bit easier because this one falls on a point. It falls on the point at 3. And so when g is 0, I end up with 3. So make sure you're going through each of these. Follow along the point to the graph. Okay, when the x equals this, the y is equal to is the question. Y equals what when x equals this function notation?